A really important aspect of graphs of equations is symmetry. And we can utilize symmetry really to our advantage so that we don't have to plot out extra points that are unnecessary. Basically it helps us to save some work if we know what kind of symmetry the equation has. Okay, so as you saw in a previous video, if I want to graph an equation with two variables, I have to plug in a lot of numbers, right? I plug in numbers for x or for y and then calculate the other one and then plot the points. And that can get tedious, especially if there's not a very immediate pattern. The one we did in the video had a line, and the line was pretty clear. And so linear equations aren't too bad. You just need a couple points, 3-4 points actually would be more than enough. 2 would be fine to get that graph. But if you start getting some curves or some other things, and there's more to it than just a line, then you really need to know what the pattern is, and you need more points to establish that pattern. And using symmetry allows us really to cut that work almost in half, maybe even less if we know what that is. So probably in half anyway. So the different types of symmetry, there's y-axis symmetry, x-axis symmetry, and origin symmetry. And let me give you an example of y-axis symmetry and how that can help us out. Let's say, for instance, I was plotting some points and I just wanted to put in positive values for x, and I found that the graph maybe it started at 0 even. I'll add a 0 in there. Maybe it kind of goes up, increasing to the right like this. Okay? Then if I know that it has y-axis symmetry, then I know that every point over on the right here will have a mirror image or a symmetric point over on the left. I'm not sure I'm drawing that very symmetrically here. Oh wow, it's way off. What am I doing? Something like this. Over here. Oh, I can't get that to work out nicely. There we go. Something like that. Anyway, terrible drawing. And so I can connect these, and you get the curve going up to the right, and you get the curve going up to the left, and you have this y-axis symmetry. You can kind of see it's the same on each side of the axis. But I don't have to plug in all the negative values for x because I just used what I had on the positive side and reflected it across. Okay? Now, a reflection basically across the y-axis means that the y values are the same. So between 2 points that are symmetric, the y value there is the same. Okay? It's the same y value on each point. The x values are opposites. There's the same distance on either side of the y-axis. And so if one of them, let's say this one over here was 4, then the other one over here would be at -4, right? They're opposites. They have to be the same distance, but on different sides of the y-axis. So the x values are opposites. Okay, so what that means then is anytime you have y-axis symmetry, there are always going to be, for every x, y ordered pair on the graph, there is also going to be a negative x, y ordered pair on the graph. Okay, so there's 2 points that are symmetrical. They have the same y coordinate but opposite x coordinates. Okay, one positive, one negative. The only exception to that would be any point that's actually on the y-axis itself is its own symmetric point. Okay, and so you might just have a point that's 0, y, in which case when you do the negative of 0, it doesn't change. Okay, so you could have that occur, but every other point that's not right on the y-axis will have a positive and negative version on the x coordinate. Okay, x-axis symmetry, very similar. Okay, but instead you fix the x value and you alternate the y, right? So if you fix an x value and you have a positive y and a negative y, that gives you your x-axis symmetry, as long as they're same distance on either side. Okay, so for x-axis you have, let me separate these off, you have x values are the same. And the y values are opposites. Okay, and so we'd have pairs of points x comma y and x comma negative y that would occur on the graph. And again, the only exception to this would be any points that land right on the x-axis, because when you because the y value would be 0, and when you negate that, you still get 0, so it doesn't move. Okay, it doesn't go anywhere. All right, so every point would fall into either a pair like this or something like this right on the x-axis. All right, that would be for x-axis symmetry. Now, origin symmetry is the weird one. It's a little bit strange, and maybe I'll even draw a separate graph for this. And so with with origin symmetry, if you have a point, we'll call it x comma y, and we'll put it right there. So there's the point x, y on the graph. Then you reflect it through the origin. Okay, and the origin is down here. It's 0, 0 on the graph, and so instead of going horizontally or vertically, you go on an angle through the origin, and you come out the same distance away on the other side. Roughly, right there. Okay, now it's supposed to be a line. This is a little wobbly here, but you kind of get the idea. I'm trying to go through the origin there. All right, and so you have this relationship. Now, what coordinates would that point have? Well, it's the same distance over on the other side in the x direction, but it's on the other side, so it's going to be a negative x, and it's the same distance in the y down, but it's in the opposite direction again, so it's a negative y. And so you have the combination of negative x, negative y, on the graph. Now, it could be the case that one of those was negative to begin with. So you could have the x, y down here in the fourth quadrant, in which case the negative x, negative y would be up in the second quadrant. So it doesn't have to be first to third. It could be fourth to second or second to fourth. It doesn't matter. So, but every point moves diagonally across the quadrants instead of horizontally and vertically with origin symmetry. And so what we say is that we'd say that the x values are opposites and the y values are opposites. And so every point would have a corresponding, if you have an xy point, you would have a corresponding negative x, negative y point. Okay? Now, like I said, the x itself could be negative, in which case negative x is positive. It's always a change in sign, so it doesn't matter which ones they start out. They don't have to start out positive or start out negative. They could start out the opposite. They could be one positive, one negative, and then switch signs. Okay, so as long as they switch signs, that's the big thing. Both variables have to switch signs for origin symmetry. All right. Okay, so that just gives you an overview. Now maybe I'll just do a couple quick examples with individual points, and then in the next video I'll give you a couple examples with some equations to work with. So for instance, in the y-axis, if I had y-axis symmetry and I knew the point 3 comma negative 5 was on the graph, so if maybe I plug in the number 3 and I get out the number 5, negative 5 for y, and I know, if I already know there's y-axis symmetry, then I can immediately put another point on the graph, and that would be the one that changes the x value but fixes the y value. And so I could go negative 3, negative 5 must also be on the graph if there's y-axis symmetry. Okay. Now let's say take that same point, 3 comma negative 5, and let's say I had x-axis symmetry. I plug the 3 in, I get out the negative 5, and I know already, I've established that there's x-axis symmetry. Then all I have to do is alternate the y value and keep the x value fixed. So the x stays the same, the y value changes, so I would know that 3 comma 5 would also be on the graph. So I've got 3 negative 5 and 3 positive 5. They're on different sides of the x-axis. Then you have the origin symmetry. Again, we'll start with the same point at 3, -5. And again, if that's x and y, then you change the sign, make it -3 and +5, right? You apply a negative to both of those. So we'd have -3, +5 would be the other point on the graph. All right, so here you can see, for any point, you can find a symmetric point based upon what kind of symmetry you need, simply by alternating the sign on the corresponding coordinate. So again, if there's y-axis symmetry, you alternate sign on the x coordinate, so the opposite. If you have x-axis, you alternate the sign on the y, and if you have origin symmetry, you alternate both signs, okay? And that will give you the corresponding symmetric point on the graph.